From the battery that's powering whatever device you're watching this on, to the giant power lines that stretch across the entire country, our whole world runs on electricity. But here's the thing we might not think about. Not all electricity is created equal. So let's dive in and really get a feel for the invisible forces that make our modern world tick.
It really all boils down to this one fundamental question. How do we take that invisible energy flowing through a wire and actually use it to make something move? Like a fan, a power drill, or even the motor in an electric car.
Well, you'd think the answer would be simple, right? But it turns out it's not so straightforward. The answer depends entirely on which of electricity's two very distinct personalities you decide to work with.
So here's what we're going to cover. We'll start with that basic electric dilemma. Then we'll compare the motors that each type of current powers. We'll look at how we actually deliver all that power. And then we're going to get into the real workhorse of industry, the difference between single-phase and three-phase power. We'll unpack the power of three, and finally, see how it all comes down to matching the right power to the right purpose.
All right, so let's get right into it. This is the first, most fundamental choice. When engineers are designing pretty much anything, they have to pick between two main contenders, direct current and alternating current. First up, you've got direct current, or DC. This is electricity in its most basic form. The current just flows in one constant direction. Think of it like water flowing through a hose. It's steady, it's predictable, it's the kind of power you get from a battery.
And on the other side of the ring, we have alternating current, or AC. Now, this is a completely different animal. Instead of that straight, steady flow, AC power is constantly oscillating, rapidly flipping its direction back and forth over and over again. This is the power that's coming out of the outlets in your wall right now.
So one flows straight, one flips back and forth. Who cares, right? Well, it matters a ton, because that single difference completely changes the kind of motor you can build. And let's be honest, motors do pretty much all the work in our world. This really lays out all the trade-offs perfectly. On one side, you've got DC motors. Their superpower, that really easy and precise speed control. That's exactly why they are in your cordless drill or an electric vehicle. But there's a catch, right? They're more complex, and they have these things called brushes that eventually wear out. Now flip over to the AC side. These things are the total opposite. They're simple, they're tough as nails, and they require way less maintenance. These are the workhorses for things that just need to run reliably for years and years, like a pump or your refrigerator. And this quote from Cruzet just nails it. It really gets to the heart of the matter. The choice is all about the application. If you need that fine-tuned control, you go with DC. But if you need a simple, durable, cost-effective workhorse, AC is your guy. So DC is fantastic for very specific jobs. But when you're talking about powering an entire city, you have a totally different problem. How do you send electricity hundreds of miles without most of it just fizzling out? Well, this is where AC plays its trump card. Its voltage can be easily stepped way up for efficient long-distance travel, and then stepped right back down to be used safely in our homes. That one feature is why our entire global power grid is built on AC. But just when you think you've got it figured out, the story takes another turn. Just because we've all agreed to use AC for the grid doesn't mean it's a one-size-fits-all solution. There's another huge decision that has to be made in how that AC power is actually delivered. So let's break down these two main systems for getting AC power from point A to point B, single-phase and three-phase. Now, single-phase power is the one most of us know. It's what you have in your house. It's a really simple two-wire circuit, one power wire, one neutral wire. It's the standard for our homes because, honestly, it's perfectly fine for running your lights, your TV, and your toaster. Three-phase power, on the other hand, is a whole different beast. Instead of just one wave of power, it uses three, and they're perfectly synchronized, each one hitting its peak just as the one before it starts to dip. This constant overlap is the absolute key. It's what creates a much smoother, more constant river of power. You know, I love this analogy. Powering something with single phase is like trying to push a merry-go-round all by yourself. You give it a big shove, and then there's a little pause before you can push again. It's kind of jerky, but now imagine three people pushing, each one starting their push just as the person before them is finishing. See, you get smooth, continuous, and much more powerful motion. That's the magic of three-phase. And that's really the bottom line here. For our homes, for small loads, those little peaks and dips in single-phase power don't really matter. But for industry, for massive motors, for data centers, for heavy machinery,
That steady, constant power from a three-phase system isn't just nice to have, it is absolutely essential for performance and for reliability. So what really makes this power of three so much better? Let's break down the specific advantages that make it the absolute backbone of the entire industrial world.
The advantages here are just staggering. First, the efficiency is off the charts. You can transmit 3 times the power, but you only need 1 extra wire to do it. Think about the massive savings in copper that represents on a national scale. It's huge. And second, there's the smoothness. Because the power delivery is so constant, it dramatically reduces vibration in large motors, which makes them last longer and run more reliably. It's just a more elegant and powerful solution all around.
Now, to actually harness all this power, engineers connect the wires in a couple of specific patterns. The 2 most common are called star, or sometimes you'll hear it called Y, and delta. You don't have to be an electrical engineer here, just think of them as 2 different circuit blueprints, and each one has unique properties that make it useful for different kinds of equipment. And here's where a little bit of math magic comes into play. Because of the way the phases interact in that star configuration, you get this incredible bonus. The voltage between any 2 of the power lines becomes about 1.73 times higher than any single line's voltage. It's like getting a free voltage boost. And this little secret is a huge reason why 3-phase systems are just so darn good at delivering serious power.
Okay, so after looking at all this, DC, AC, single-phase, three-phase, what have we learned? It's that there is no single best type of electricity. It's all about finding the right tool for the right job. The real takeaway here is that every choice, from the DC in your cordless drill to the single-phase AC in your kitchen, all the way up to the massive 3-phase system powering a factory, is a very deliberate engineering decision. It's all about that careful match between the power source, the way it gets delivered, and the specific task that needs to get done.
And that's what's so fascinating, isn't it? This invisible dance of power. AC versus DC, single phase versus 3-phase, it's happening all around us all the time, and it's what makes our modern world move. From your laptop to a high-speed train, this is what's behind it all. The only question left is, what will it power next?